Hello, welcome to another one of my recordings. Through this recording, I just want to cover some of the concepts covered in Chapter 2 of your textbook on basic elements of C++. So I'll have a demo and we kind of walk through these slides and hopefully it'll give you enough background as you read your textbook. So go ahead and start here. So essentially, what you want to do, what we're going to be talking about is variables and data types and assignments and expressions. We'll also cover basic input and output to C++ programs. So let's just go in here. Well, of course, some of this stuff you already know about, that a computer program is essentially a set of instructions to tell a computer what to do. And in order to write a program, obviously you have to understand the problem and write an algorithm, which is another name for a recipe, to solve a problem. So I have posted some material on writing pseudocodes that you all should be familiar with. So here's a quick look at a C++ program. This is right out of your book. So what I want to do is, instead of showing you this, we'll go ahead and open it up. And of course, hopefully you already know how to get your source code for all these chapters. That way you don't have to type the code. Of course, to begin with, it may be a good idea to type some of this stuff and make some mistakes as you go. But again, all this code is already available for you. I've already installed dev C++ on my computer. So notice the CPP file here is already associated with dev C++. So all I'm going to do is double click it and it will open up dev C++. Now I have version 4.9, version 5.0 is already out. So when you look at this example, you'll see that we've declared our variables. In this case, 4 variables. We have a cout statement, which displays something out to the screen. We have some assignment statements for the length and the width. We find the perimeter using this formula. We find the area using this formula. And one thing you notice that this program doesn't have too much documentation. So we really don't know what we're doing here. So we may want to document this with something like finding the perimeter. Essentially, just explain what a single formula or a single expression is doing. And this one would be finding the length. And of course, cout will display. The way you read cout is you go from left to right. It will display the literal string constant length equals, followed by the insertion operator that follows it by the variable length, and then end L essentially goes to the next line. So if you don't include the end line, all your output will be on the same line. So in order to run this code, all I have to do, of course, in dev C++ is to click on compile and run, or click F9. So when I compile and run this code, you'll notice that it actually showed me the results and went away. It's just because this version of dev C++ doesn't wait for me to essentially see what the output is. So one way to stop the output would be something like creating a variable like int x and then using cin x, meaning that the program will pause for you to enter a number. So that would be a quick way of pausing the window. Again, if you're using any other IDE, you just have to find out what's the best way to control your output screen. So you'll notice that the length and the width and the perimeter and area is displayed, and again, it's waiting for a value. So if I just put in 1 or something, press enter, it will go away. Okay, so essentially this is the structure of a typical C++. Of course, this code doesn't ask for input. We just hard-coded the values of the variables that we're going to need in order to calculate the perimeter and the area. So let's go back to our slides. So we show you a sample run, and the good thing about these slides is that they kind of pinpoint that you've got your comments. you've got your variable declarations, you have your assignments right here, you have your output, and that kind of walks you through the process. So essentially a variable is a memory location that can vary or whose contents can be changed. So the length, width, area, and perimeter, think of them as essentially pigeonholes or slots in memory that are ready to be assigned values. So when we make an assignment length equals to 6, that's what happens. Length becomes 6. In other words, from now on, this variable has a particular address in memory, and that address is associated with the constant 6. So I'm going to kind of walk through this a little bit faster again, so hopefully you can read all about this. So comments, we have two types of comments, multi-block with /* or single inline with //. No spaces between the slashes, by the way. C++ has a whole bunch of special symbols like the plus, minus, star, slash. So again, some of these should be, actually all of these should be familiar to you. So we have reserved keywords, things like data type definitions like int, float, double, char. These, of course, cannot be used as variable names in our programs. Identifier, again, is essentially the name of a variable. So it's the name of something that appears in a program. So length equals to length is a variable or an identifier that's associated with a value. C++ is case sensitive. Here's a basic rule for creating your variables. And we have these two predefined identifiers, are cout and cin. Cout allows for console output, cin allows for console input. So there is a thing where you can actually redefine these, but it's not a good idea at all, because then the program is going to be very confused. So we want to avoid redefining any predefined identifier. So legal identifiers in C++ or anything essentially starts with a letter, no spaces, no punctuation marks. Those are all valid variable names. You can read about that. Data types, essentially in C++, you have to tell the computer about the type of value a variable can hold. So if you're thinking about storing people's ages, maybe you want to create an integer data type. If you want to store people's names, we'll use a string data type. For somebody's letter grade, maybe a character data type. So the data type is dictated by the type of value you're going to store in a variable. Now, in this class, we talked about both simple data type and structured data types, but pointers are covered in CIT 233, or the Advanced C++ course. So some of these again, all data types have predefined values that dictated by the compiler you're using, and so read all about the limits of these things. So integer data type are whole numbers. So again, no commas in numbers. Boolean essentially is a data type that can only hold true or false, and character data types, just single characters. And then, so we'll talk about these. Again, you'll have to read through the book for some of this. I just want to make sure you cover most of these slides in about 30 minutes, because I hate for these to be too long. But decimal numbers all have a decimal, essentially a point in them or a period in them. And C++ allows for scientific notation, which shows up with the letter E in it. And you can also input values with the letter E. So the difference between float and double essentially is the precision and the size of this data type. I usually just stick to the type double, because although the only difference between these is that float take up half as much memory as double. So it really depends on what type of programs you're writing and what type of precision and how big of numbers you need to store. So the way you identify or create or define variables is the data type followed by the variable. So in our C++ program, that's what we did. The data type double, length is the variable. And that essentially tells you how to define variables. You can also make an assignment. Well, actually, you make an assignment using the assignment operator or the equal sign. So C++ allows for arithmetic operators, all the common ones. The modulus operator is a little bit different because what it does is it gives you the remainder of division of two numbers. So essentially, if you think about this, 10 divided by 2 gives you 5, but 10% 2 or 10 mod 2 gives you 0, because if you take 10 divided by 2, you won't have any remainder left, because there's 5 10s in there's 2 5s in a 10, and that's how division or the modulus operator works. And there's some good applications of this modulus operator. Kind of makes your life easier by using it. So we'll only use percent operator with integral data types or whole numbers. So going around this, you should all know about the order of precedence. Of course, if you have parentheses are always evaluated first. And here's the basic rules for order of precedence. By the way, exponentiation, taking something to the power of another thing, is way even before this level. And your textbook has a table of precedence, but if you use parentheses, you don't have to worry about precedence rules, really. So expressions, essentially all operands are integers. So if you have 2 plus 3 times 5, you're going to get another integer. If you use decimal numbers, the result is going to be a float. If you mix an integer and a float, essentially float or double win. So the integers are automatically converted to double before being used in the expressions. So you could mix your expressions, and C++ by automatically performs its own magic on these numbers. So again, read about these rules. Cast operator is a good one, because what you can do is that within an expression, you can actually change the data type of a variable. This way, you don't actually, of course, you cannot redefine variables in C++. So if you define length as a double here, then you can't come back here and say, well, okay, I'm done with that. Now I want to say int length. If you did something like this, you will get a compiler error telling you that you're attempting to redefine it. So variables cannot be redefined. So notice it tells you that there's a conflict declaration. And of course, different compilers have different rules or different messages. So you don't want to redefine variables at all. So if you happen to need the integer equivalent or a double equivalent of a variable, you can do a static cast with that variable. So static cast int 7.9 will truncate 7.9 and converts it to an integer. So again, read these slides or read the books, chapters in the book, and let me know if you have any questions about how these things are operating. But they should be pretty straightforward. The string type is a special type, essentially, that allows you to hold a string of characters. Now, the string is really more than a type. It's actually a predefined class, which means that it has a whole bunch of functions, which we'll talk about later, I believe, in Chapter 4 in a little bit more detail about some of the functions associated with the string data type. So all string constants, by the way, are embedded in a pair of double quotes. So variables, assignments, and input statements. Again, the idea is to define a variable, such as length, make an assignment to it, and then use it throughout the program. Of course, you can always change the value of a variable. Now, if you add the keyword const in front of it, all you're doing is you're creating a constant data type that cannot be changed, or a constant variable that cannot be changed. So for instance, if I just say const double length equals 8. All I'm saying is that I'm assigning length to be a double, and it's going to be a constant. So notice what happens when I try to redefine length right here. So I'm going to compile this, and right here it's telling me that, hey, this is read-only, it's constant, and you cannot change it. So obviously, if you have to think about this, the things that you don't want to change, let's say the name of a company, or the tax rate, or a common modifier, could be a conversion rate, or number of students. They all are good candidates to be constant. The rule, again, the idea here is that by doing so, the compiler will tell you if your program attempts to change the value of a constant. So really, you're protecting yourself against yourself. So let's continue on. So we talk about variables. The way we putting data into variables, of course, one way would be to make an assignment, or which is again, we've seen these examples before, and then assign an expression or assign the value of an expression to a variable. By the way, the expression would be anything on the right side of the equal sign, which could involve constants and even variables. So I could say sale equals num1 plus num2 times this. So essentially, this is how we do initializations. Cin is the essentially is the statement that allows us to read input. So if I go in here and instead of length equals to 6, I could just do Cin length and comment that, and then I'll do Cin width and put a semicolon, comment that. Now the only difference between this code and that code is that this one is going to ask you for something. Of course, I didn't prompt it. So we should put a prompt right before the Cin asking the user to input or what type of value to input. So if I say 10 and 2, 10 would be the length and 2 would be the width. So now you get the same calculation. So of course the nice thing about input is that the program now can be a general purpose program that will allow you to read data. Now of course you can read more than one value using Cin, which is really not recommended. So instead of doing Cin feet and inches, which will expect 2 values for, in this case, feet and inches, it's better to do it this way, where we have, again, maybe a prompt right here that says cout, enter the length. You may want to put a space in there and a semicolon. Of course, notice I didn't put an end line at the end. So the cursor will stay on the same line, waiting for you to type the length at the same line. So so there's a good example in your book. So we'll talk about that now. Variable and variable plus plus. These are called increment operators, and they're kind of shortcuts. Which the only type of shortcut that I really like is just pre or post, it doesn't really matter, with single variables. I don't really like to use these in assignment because they could be confusing because of the order of precedence, but you should be able to know how they work. So, so again, read your book on this, and we'll also talk about it in class, I guess, if we meet in class for this course. But essentially, in this case, what we're saying x is equal to 5. And then y equals plus plus x. Now in this case, we're going to increment first and then make the assignment. As opposed to y equals to x plus plus, which means that make the assignment first. So make y equals to 5 and then increment x. So as you can see, it's kind of confusing because you're doing 2 statements in 1 statement. Okay, so the stream insertion operator is used for cout. And by the way, one way I kind of tell people to remember this is the way these arrows go is that if you are putting a value into a variable, you're kind of directing or pointing to the variable. And for cout, we're kind of saying we're giving it, giving something to it, to the cout. So, but again, you just have to make some, with some practice, you'll memorize this in no time. But just that might help at the beginning to figure out which way the operator is going to go. Of course, if you make a mistake, the compiler is going to know, and then you go change it the other way. So I'd like you all to make sure you go through these exercises, make sure you understand that the escape sequences of /n, new line, and /t, they're actually used within strings so that they'll do special things. And you can read your book on that. The preprocessor directives, essentially C++ doesn't really have a large number of operations. Instead, all of the functions that we use are stored or saved into these predefined libraries, which we call preprocessor files or preprocessor directives. And what we do is essentially we include the content of the preprocessor data, meaning definition of functions, in our code. So here when we say pound include IO stream, all we're saying is that, are we telling the compiler to include the definition of whatever it is in this file as a part of our code. So essentially cin and cout is one of those functions that's defined here. And essentially that allows the compiler to just compile these predefined functions. And so we will talk about these preprocessor directives or the pound include in a lot more detail when we get to the advanced C++. Okay, so notice here if you want to use the string functions, you'll pound include string. It does string library. As you may have noticed that all C++ programs include the main. Now main can have parameters. Those are called command line arguments. You always have every function in C++ starts with a bracket, a curly brace, and ends with a brace. And because this function is returning a value, we're going to return value. Now this value returned, whether it's 0 or 100, it doesn't really matter because it goes back to the operating system. So let's go back in here. And again, declaration statements are things that define or declare variables. And these are called execution statements. So you can see in and see out. These are statements that actually run things for you. So the CPP file, the .cpp file is referred to as source code. And the compiler generates an object code. The linker takes this object code and links it with all the libraries that we need, and it creates an exe file. So you notice that when I go to this folder, we created an exe file that I could just double click on and run. So you can run and this is an exe file that you can give someone else to run on a Windows machine. So again, this is our source code. This is our executable code, and and of course there's an object code that gets created. Okay, and now if you make any kind of mistakes, of course, if you don't put that semicolon, now you're asking for it, because what's going to happen is it's going to give you an error message. Now notice here it pinpointed the error here, but the error was really up there because compilers are detecting errors line by line. Essentially, it has already passed this line before it got to this line. So anytime you get an error message, always look up and see if there's anything you missed. Obviously, I missed that. And then you compile again, and it will run. So most of your time may actually be spent on finding compiler errors. Okay, so again, depending on the compiler, it will tell you what line the error is, and it will tell you what the error is all about. Syntax rules. So int x ends with a semicolon, int y needs to end with a semicolon. So all C++ statements end with a semicolon. Use of blanks. Again, C++ actually ignores all sorts of blanks, so you can, but you need at least one statement, a lot of times, or one space to separate reserved keywords. So if you're essentially if you're saying double length, you can't do that because then you don't have at least one space between these two. So if you did that, of course, you're going to get a compiler error. But of course, if you did this, it doesn't really matter, but your program will just not be as readable. You always want to have one space only between the variable identifier and the variable name. Okay, so all C++ statements end with a semicolon. We talked about that. Functions or blocks of code are within braces. And semantics refer to the meaning of a language. So notice here 2 plus 3 times 5 is different than 2 plus 3 times 5. Both are correct as far as syntax goes, but they have different meanings. The naming of identifiers, read all about that. You definitely want to create variables that are descriptive. So instead of length and width, I suppose I could have just used L and W, or len or width, or the length of my yard, or the width of the yard. So just make sure that these things are not too long. Of course, there's no limit to how long these names can be, but don't make them too long because then you can't take care of them. You can't control them. Documentation is essentially telling people what you're doing in a program. Now, for your assignments, I have some examples of proper documentation. Your books examples also give you a lot of information on how to properly document your code. This method of defining variables is perfectly fine, but this is not. So don't try to declare two different types of variables in one statement. It'll just be very hard to read. I actually prefer breaking my variable declaration statements in this fashion, so I create a variable dictionary, making it a lot easier to read. Okay, so two forms of assignments. Remember, we have x equals to x times y. This just says take the value of x, multiply by y, and put in x. You want to do this compound or a shorthand statement. You can actually say x times equal y. Again, this is hard to read. This is easy to read. For this class, I actually prefer you do write your statements this way, but you should be able to read programs that are written this way because there are a lot of programmers that use these compound statements. So so be careful with the compound statements. Don't overuse them. Okay, so in summary, what we just talked about is that a C++ program is a collection of functions, one of which is main. Of course, in this case, we only had one function. We know that we have identifiers that have a rule to them. We can use arithmetic operators. And we already talked about how these operators are actually performed or evaluated using the precedence rules. So this is pretty much it. I think I've gone about 30 minutes, so I'm going to stop right here. I hope this was helpful. I will post this, of course. This is already in the recording section of your Canvas course. So if you go to Canvas course right here, you will see a link for all the recordings for this class. So this was a recording for Chapter 2. I will have a similar one for Chapter 3 and so on. Again, I hope you enjoyed this. I hope you find it useful and ask questions. Goodbye for now.